The results from this hot, Jupiter-like planet that was first characterized with the help of the CHEOPS Space Telescope, may help astronomers understand the complexities of many other exoplanets, including Earth-like planets. The atmosphere of Earth is not a uniform envelope but consists of distinct layers that each have characteristic properties. The lowest layer that spans from sea level beyond the highest mountain peaks, for example, the troposphere, contains most of the water vapor and is thus the layer in which most weather phenomena occur. The layer above it, the stratosphere, is the one that contains the famous ozone layer that shields us from the sun's harmful ultraviolet radiation. In a new study that appeared in the journal Nature Astronomy, an international team of researchers led by the University of Lund show for the first time that the atmosphere of one of the most extreme known planets may have similarly distinct layers as well, albeit with very different characteristics. An exotic cocktail for an atmosphere WASP 189b is a planet outside our own solar system, located 322 light-years from Earth. We measured the light coming from the planet's host star and passing through the planet's atmosphere. The gases in its atmosphere absorb some of the starlight, similar to ozone absorbing some of the sunlight in Earth's atmosphere, and thereby leave their characteristic fingerprint. According to the researchers, the gases that left their fingerprints in the atmosphere of WASP 189b included iron, chromium, vanadium, magnesium and manganese. An ozone layer on a blisteringly hot planet? One particularly interesting substance the team found is a gas containing titanium oxide. While titanium oxide is very scarce on Earth, it could play an important role in the atmosphere of WASP 189b, similar to that of ozone in Earth's atmosphere. Its detection could therefore indicate a layer in the atmosphere of WASP 189b that interacts with the stellar irradiation similarly to how the ozone layer does on Earth. Study co-author Kevin Heng, a professor of astrophysics at the University of Bern and a member of the NCCR Planets, explains. We believe that strong winds and other processes could generate these alterations. And because the fingerprints of different gases were altered in different ways, we think that this indicates that they exist in different layers, similarly to how the fingerprints of water vapor and ozone on Earth would appear differently altered from a distance, because they mostly occur in diff. These results may change how astronomers investigate exoplanets. A different way to look at exoplanets. In the past, astronomers often assumed that the atmospheres of exoplanets exist as a uniform layer and try to understand it as such. But our results demonstrate that even the atmospheres of intensely irradiated giant gas planets have complex three-dimensional structures. Study co-author and associate senior lecturer at Lund University Jens Hoimakers points out. We are convinced that to be able to fully understand these and other types of planets, including ones more similar to Earth, we need to appreciate the three-dimensional nature of their atmospheres. Note: content may be edited for style and length. 2022, January 28. Extreme exoplanet has a complex and exotic atmosphere. Science Daily. Retrieved January 28, 2022 from bit.ly/3@s University of Bern. Please support my channel to grow by pressing subscribe button and the bell icon. We will notify you technological news. Thank you.